Hello, everyone. And thanks, Alex and Ben, for inviting me over. Great pleasure. Literally my very first in-person presentation since lockdown, so this is a big deal. I'm really excited. And it's so different, actually, looking into real faces. And I'm looking forward to hopefully having some interaction and some Q&A later as well. In terms of introduction, Alex already said a few things. Mathias Thierbach. I work as head of finance systems for YouGov down in London. I run basically I run a data management and data analytics team embedded in the finance function, and have done so for 5-6 years now. Prior to moving into management and data analytics, I've spent over a decade in software engineering and software architecture. So yeah, basically a mix of a lot of tech as well as management and team building. My big thing nowadays is Power BI. And in particular, PBI-Tools. Alex mentioned it's a Power BI open source tool, which been working on for quite a few years. However, it hasn't become public, if you will, until end of last year. So it's still relatively new kid on the block as far as Power BI is concerned, and it's going to feature heavily tonight. In terms of agenda, what I want to talk about, I want to cover what is pro model development in Power BI, and specifically how can PBI-Tools actually help with that. So I'm going to talk about, well, what is pro or professional model development? What am I looking for? Gonna start with a little problem statement here. Introduce PBI-Tools in just for those who haven't heard of it or want a refresher. And then it's mostly going to be demos and basically showing stuff. So what I want to get across basically is my way of working when it comes to Power BI model development in a team context or in an enterprise context, which I've basically developed, if you will, over 5 to 6 years, in conjunction with also building out PBI-Tools to actually help close the gaps. So there's quite a lot of learning that's gone into this, and yeah, just want to sort of talk about what we in my team care about when it comes to model development, what I think works well, and hopefully also have a discussion with everyone. Yeah, that's pretty much what I've got here. So let's dive straight in, if that's okay. If you look on the left-hand side, the red block, that's I've put a few bullet points down here in terms of what I'm looking for when it comes to professional or enterprise level model development. This is my wish list, if you will. So, for instance, we got to ensure that production is always guarded, right? There can't be any risk in stuff just slipping into production. We also want to make sure that versions, and particularly previous versions of whatever I've got in production, is accessible to everyone and is not something that easily gets lost. Particularly, we need to know what's actually changed between different versions for models as well as reports. As a developer, I want to get quick feedback, right? I don't want to be in a position where I spend a lot of time doing some modeling, but then I don't really know what that looks like in PBI service, for instance. a code repository should be the source of truth when it comes to Power BI artifacts. Ideally, developers shouldn't have direct Power BI publish access, because that basically gives us an issue in terms of guarding production, which means ideally we want to have some approval workflows in place before stuff gets into production. And also, the other thing is we want to ideally be in a position where multiple team members can actually collaborate on the same project and actually work on different changes and features in parallel. So that's my wish list. Hands up if you think that I'm mental and this is something we can never achieve in the Power BI world. Hands up if you think you're already there and this is actually how you work. Right. So what I want to present today is basically, I think I've more or less achieved all these items on that list here, and so effectively that's the topic of the talk. The components we're looking at, right-hand side, automated deployments, all artifacts under source control. We've got multiple environments, production and other environments, and we've got a branching model, particularly allowing collaboration. And the tools we're looking at, PBI-Tools, obviously, Power BI Desktop, Git and VS Code. I'm going to be demoing GitHub Actions for deployment automation, but you could just as well use Azure Pipelines or any other CI/CD tool. And if we have time, a bit of TE and DAX Studio as well. All right, let's introduce PBI-Tools, just for whoever is not aware. It's an open source Power BI external tool, pretty much exclusively run by myself right now. I really hope to get in a situation where I've got a few more collaborators here. So the core purpose of PBI-Tools is to move from having this PBIX file, which is just a black box file, and actually enable us having a concept of a project with artifacts, with all the internals that make up what's in a PBIX file, and make those visible. And then also allow things like automation and deployment. So the key idea of PBI-Tools is what I'm calling the PBIX proj format, which is basically a folder structure, a standardized folder structure that contains everything that's in a PBIX file, but in such a way that you can actually reason about it, and you can see, if you change a particular setting on a matrix visual, you can see exactly where that change comes through, and the same applies to model. So that's the key idea here. You can basically take a PBIX file, convert it or extract it, as I call it, into a folder structure, which then fits nicely into source control. And you can go the reverse. You can basically take what you've got in source control and convert it back into a PBIX file or PBIT file. I call that compile, and that then obviously allows things like automated deployments. So extract, compile, deploy. Those are the three features, and I'm going to show lots of that later today. If you want to see other presentations I've given on PBI-Tools in particular, go to the link, go to PBI-Tools/YouTube. There are currently 17 recordings on there, with 2 pending, which are already out there. I haven't added yet. This is going to be number 20, basically. So quite a bit of watching you can do there. Cool. Let me just do this one very quickly because I've basically introduced it already. So idea is we develop, obviously, with the PBIX file using Power BI Desktop, but also other external tools like Tabular Editor, DAX Studio. And If we then extract that into the PBIX prod folder structure, we get to the middle layer here, where we're in the source control world, where we're using Git and GitHub and VS Code and Azure repos, etc. And if we then again take that Git repo and recompile it, we move into the CI/CD world, where we basically deploy Power BI artifacts straight out of source control. So that's the idea here. Don't want to bore you with too many slides, so let's get our hands dirty. I've set up a public GitHub project, which is accessible to anyone here, which basically has everything I'm showing in it. So you can basically go take a look and clone it or learn from it. It's the dataset DevOps demo in the PBI-Tools GitHub org. And I'm using a Contoso PBIX data model, which is basically one of the samples provided by SQL BI. What distinguished in 3 different environments, pretty standard, dev, UAT, production. We're using milestones and issues within GitHub in order to plan what goes into our releases. We're using a branching model where a particular branch is basically mapped to particular environments. Deployments are triggered fully automatically. And then lastly, deployments are configured or described, if you will, using a manifest. So rather than having long, difficult scripts to read through and understand, PBI-Tools deployments are actually data rather than commands or scripts. Let me show you what that looks like, if that's okay. I'm just gonna sit down and go into Power BI to start with. So I've created a couple of workspaces here. This one is the datasets prod workspace. I've got Contoso sales in here, which is a model, and then I've got a report linked to that same model. We can see sales by product, sales by geography, and some other stuff here. So we've got that. We also have datasets dev, which is a different workspace, and it also has a different instance of that same model with a dev suffix. It also has a report, shows a few other things here. So we've got that. We've got this repo I mentioned earlier, which I've got open on my machine. So let me just make this a little bigger. Can you read that okay? Right. So what do we have here? Basically, anyone who has never seen VS Code before? Okay, cool. So I've got a folder open, which is basically a clone of that same repo. I've got Contoso sales as a subfolder in here, and that basically is the PBI-Tools representation of a Power BI model. Of a Power BI PBIX file, which includes a model, but it also includes a report, as you can see, and static resources. The model has tables, and tables have columns, and some of them have measures. So this should all look pretty familiar if you're familiar with Power BI models. And also, if you've worked with Tabular Editor and the Save to Folder output format, then that should look familiar. It's not exactly the same, unfortunately. There are some differences here, but conceptually, it's the same thing. And so we've got that. And we have the deployment manifest, which I talked about earlier. Here we go. Let me just collapse a few things. Let's see what we've got here. So what can we recognize? First of all, we're saying this is a dataset deployment. By the way, that is a brand new PBI-Tools feature. Today was the occasion for me to actually finally get this done. So previously, PBI-Tools only supported report deployments. As of last night, we have fully automated dataset CI/CD pipelines available with PBI-Tools. So dataset deployment mode, we define where our sources are. We've got a folder as the source type, and then the Contoso sales subfolder, the one we've already seen before. We deploy into PBI service, Power BI service. Hence, we need to specify authentication. Because this is all automated, we're using service principals. So basically, I'm specifying client ID, client secret. Obviously, I'm not putting a client secret in here. In fact, this is a environment variable reference, which gets injected at runtime securely. And that service principal is already in place, and it's got access to the 2 workspaces we've seen before. Then the other thing I've also talked about, we've got 3 environments: development, UAT, production, I mentioned earlier, right? So let's see what we're saying here. Pretty straightforward. If we're deploying into development, it goes into the workspace called datasets def. We've seen that earlier. The display name, which is basically what is the dataset called in Power BI, uses a parameter, which is the folder name. So in this case, Contoso sales, with the def in square brackets appended to it. And then the other thing, not only are we deploying models, we're also refreshing them automatically. So this is part of what PBI-Tools can do as of last night. So basically, if we're running a development deployment, we're grabbing the sources from this subfolder. We're then converting it into something Power BI understands. We're sending it into the workspace, and we refresh it as well. And the same thing happens for the other workspaces. Just the naming conventions are slightly different. So UAT goes into the prod workspace, so does production, and the UAT version has a UAT suffix. So that's that. And in order to get this to work within GitHub, we're using GitHub Actions. So let me just go back here. So again, this is my repo. I've got actions here. As you can see, this has already been running for quite a while. And we can see there are 3 different workflows: deploy dev, deploy UAT, never run, and deploy prod. I guess it's pretty obvious what they all do. Let's take a look here, for instance. If I click on one of those previous runs, I get the full outputs which were emitted. And in here, there is one. It looks like I'm not signed in. There we go. I need to. Sorry, that's silly of me. If I had done this in Chrome, I would have been signed in. So there we go. So now I can actually see. Basically, what we were just looking at is what you will see when you only have public access. And this is what I can see when I'm fully signed in. So probably a bit too small here. Let me make this a little bigger. So this is actually where the magic happens. This is all PBI-Tools reading the manifest, the one we just looked at, and then basically interpreting, where are my sources coming from, what am I supposed to do with them, and then pretty much executing that. And PBI-Tools is giving you pretty extensive outputs here for troubleshooting. There's no such thing as logging too much, basically. So we can basically read through this very nicely. So what's happening here? PBI-Tools read project settings, which is basically the manifest. PBI-Tools then determined that we are deploying Contoso into development. We then received an access token using the service principal credentials. We then resolved the workspace ID for datasets dev, because for APIs, we need to use IDs, not names. PBI-Tools then connected to the XML endpoint for that particular workspace. Then some magic things are happening. I'm going to cover those later. And then we're saying there's an existing data set. So basically, I want to update that rather than create a new one. It's giving me some metadata. That's the name, compatibility level, when it was created, and all of that. And then line 37, you can see the model was updated. And eventually, I'm getting some metadata from the Power BI API, telling me what the web URLs and stuff like that. And if we then scroll down a little bit, here we go. Right, and then refresh starts. In this case, it's doing a full refresh. And unfortunately, I don't have lots of useful outputs here. This is only interesting when there are warnings or errors. When everything works fine, there's basically no output. And that's it. And so the whole thing took 16 seconds. Basically grab the model sources, push them over to Power BI, update the existing data set, do a refresh. Obviously, for demo purposes, I'm cheating a little bit. In terms of the refresh itself, this has got some fairly trivial data, right? So we wouldn't want to wait 20 minutes or so for a data set to refresh here. So that's pretty much what we're getting here. And then everything else is just a little bit of plumbing in terms of what GitHub needs to do. Let's figure out how those automated deployments are actually triggered, because that's a very important part of the process here, and that's quite important for us to understand. So just going back here, this is where we get to a branching model. All right, let me just have. Okay, so I've talked about 3 different environments, right? Production. What is production? Obviously, that's out in the wild, in front of end users. We better make sure this is stable and reliable and up to date, right? As far as our repository is concerned, the main branch, by convention, it corresponds to production. So we can basically assume that whatever is in main is always exactly the same as what's currently in production, and vice versa, right? The model I'm using, and I've been following for quite a while with my team in terms of putting changes into data sets, we use a release model where we basically plan a particular release For instance, we're currently on 1.2, and we think about what should 1.3 have, right? Or 1.4. So we plan what goes into 1.3. We create that as a milestone with the corresponding issues and bugs. We start each new release by basically creating a new branch of main, which corresponds to that future release. So this is the second item here on the right-hand side. That's basically an integration branch. So as developers are making contributions in terms of their particular work items, they incrementally get contributed to the integration branch. That's where CI is coming from, continuous integration. Any work submitted by a developer that's been signed off goes into a release branch and is basically ready and waiting for the release to be completed. And individual developers work on issue branches. So every single change is spec'd in this case, GitHub issue, be that a bug fix or a change. So issue gets assigned to a developer. They create a new branch working on that specific issue only. Put all the changes into the branch they deem necessary for it, and then they raise a merge request or pull request, as GitHub calls them. Looking at the pyramid on the left-hand side, we can basically see as we go up from local dev UAT to production, hopefully control and quality goes up. As we go down, we get more and more activity, right? We don't want to see lots and lots of random changes in production, but we're fine, obviously, to see that in development. So that's the idea here. And in detail, what that looks like, hope it's not too small, is that we basically do development in issue branches. When a developer, and this is crucial, I'm going to demonstrate that in a bit as well. When a developer deems their particular work to be ready for review, they make sure that everything's been pushed to the issue branch, and then they raise the pull request for this to be pulled into the release branch. And that pull request actually triggers the dev deployment, right? So this is how we get deployments into the lowest environment, if you will. Also, when a pull request is already in place and further changes are made to it, again, that actually triggers a deployment, which also means, hypothetically, if you have multiple developers working in parallel, they could potentially sort of override each other's work because there's only one dev environment. Not each developer has their own. So that requires a little bit of coordination. But I think in practice, I mean, I generally don't have a problem with that. I don't have 50 people working on the same project. It's only 2 or maybe 3, and so yeah, that's something you can communicate about. Cool. So my work as the manager only starts once I've got the pull request, because this is basically where all the interaction happens, and we can see that in a second, because GitHub makes it a very nice and smooth process. So having the pull request means the developer says, "I'm ready. Have a look." And this is then where reviews start. This is where back and forth starts. This is where we have a conversation. This is where usually more changes are necessary. It's rare in my experience that a pull request makes it all the way through to the next stage without any further changes there. So this is then where having a technical lead or a release manager or whatever you want to call it is very important for that feedback. But also, I was talking about immediate feedback as far as developers are concerned. All they have to do is to raise the pull request or make further commits to it in order to actually have their stuff automatically deployed, right? So that's pretty quick, particularly when you've got a data set, as we've seen, that refreshes in just a few seconds. So that's development, and we generally do that on PPU capacity. Means it's not well. So I mean, I should probably have started with that, but because this process relies on an XMLA endpoint, unfortunately, pro users are out of the game, right? Basically, there's no automation when it comes to Power BI Pro. You're back to uploading files into a service. So this is, you've got to have access to XMLA endpoints, either using Azure Analysis Services or Power BI Premium. So for development, I always use PPU capacities, which means developers can go wild. There's absolutely no risk that any heavy workloads suddenly impact production. And for UAT in production, I use premium capacity because obviously whatever is in UAT or production needs to be shared with the rest of the business. And those people usually don't have PPU licenses, at least not in my workplace. All right. Yeah. So how does stuff get into the release branch? Basically, a pull request is closed, right? So I talked about the iterative review. At some point, we're done. I'm happy. Everyone else is happy. We close the pull request, which means those changes go into the release branch. And that, again, triggers a deployment, an automated deployment, this time into UAT. So at that point, we've signed off a particular feature, which means the release manager can actually go and engage with stakeholders and get external feedback. Yeah. Now the other thing I've come up with, which is production trigger. So development and UAT, as we've just seen, is basically triggered by activities within the dev team, right? And as we've also seen, particularly if you then link dataset refreshes to those deployments, and if you work with real-world data rather than just my sort of dummy data set here, a data set refresh, obviously can be quite intense in terms as far as your capacity is concerned. So you want to make sure that refreshes in production aren't triggered arbitrarily or in sort of unexpected times, and so. Which is why for production, for main, we're not using activity-based triggers. We're actually using schedules. And the schedule determines actually, it's the other way around. The schedule determines when do I want my model to be refreshed. And we're saying right before you kick off the model refresh, just make sure that you have the latest model definition deployed, because oftentimes you've got to have the two work in conjunction, right? The schema update as well as data refresh, and so. I've put here every 10 minutes. So this is the schedule I've set up for my demo project. You probably wouldn't do that in a real world project. This is saying for production, the trigger is basically what should be your refresh cadence as opposed to the update cadence of your schema. And let me. Yeah, so let's look at some stuff then. So I've already started, where do I want to go? Here. I've already created a few issues here to basically demonstrate what that might look like. First of all, if we go into production, we can see that the model version at the moment is 1.00, right? You can see that. And I'll talk about how that actually makes it into this report in a second. So basically 1.00 is my production model. So what I'm currently working on in terms of my next milestone is 1.1, right? Any subsequent changes are going to go into the 1.1 release. And I've got two issues here. First of all, I didn't like the number formatting I was getting from SQL BI, so wanted that to be changed. And there is a margin measure. So we basically, Contoso has sales amount and cost, and then it calculates margin. I'd quite like to see margin as a percentage rather than just as a dollar amount. So that would be the other one I put in here as a change. And I've already started work on issue number 1, which is number formatting. So basically, this is those are the specs I've given myself. Drop the decimals and make sure that we actually have a dollar currency sign. Because this is basically what we were getting from the 1.0 model. And we can see this is linked to the 1.1 release. And we can also see, if we go to branches, that here, this one, there's a issue branch which is referencing the issue number, issues 1. And then I'll just put my initials there as well. So that's that. And I've already done some updates. And this is basically where tools like GitHub or Azure or GitLab or whatever, Bitbucket, whatever you want to use, are very nice. And again, I'm actually in the wrong browser. My apologies. I need to go here so that I'm logged in. Right, here we go. That's the one. So you can see I actually made one commit here referencing issue number 1, and we can see how the PBIX proj folder structure now really comes handy, because we can basically see from the path of the file which has changes, which particular model element we've changed, right? So here we're in the sales table. We've made a change to the margin measure, changing it from this particular format string to that one, which is precisely what we wanted. The same for sales amount and total cost, and that's it. Pretty straightforward, fairly easy, and merely committing that to my branch does nothing. But the minute I create a pull request for it, I actually get the stuff pushed into dev automatically. And again, this is also something I've already done. If I go to pull requests, I can see here, I've got a pull request that's currently still open. It's saying it's requesting to merge from the issue 1 branch into release 1.1, and it's actually linked to the issue number 1. We can see that down here. So all very nicely integrated, and again, Azure DevOps does exactly the same. And now we can see not only which commits I've made, but we can also see that GitHub has run some checks for us. And this is basically the deployment. This is the deployment which gets triggered whenever a pull request is created or updated. So that means those 3 changes of the format string should now be available to me in my dev workspace, and that's precisely what we can see here. So first of all, looking at the metadata, I can see this data model has a 1.1 version. It's what's the here? Nope, that's the one. It's the development environment. It's that's where it's coming from in terms of GitHub. So we can see all of this, but most importantly, this is actually what I wanted to achieve. And as we've seen before, it took about 20 or 30 seconds for this to actually go live in production. So my new format strings are applied here. Now, I just wanted to take advantage of the fact that the merge request, the pull request, is still open, which means if I push additional changes in the pull request, I'm going to get another deployment triggered. So I'm gonna show that. Here we go. So this is my working folder. It's linked to the it's linked to the issue 1 branch, as we can see, and I've got a few further changes I've made, which I haven't committed yet, and I did that intentionally. So basically, we can see those changes here are actually in the report. We can tell from the path contoso sales/report, and I think I just added a few or one visual to actually verify that my changes were as expected. So I'm just gonna commit those to some report updates. It's always recommended to put a reference into the issue we're actually working on. Commit. Now, if I so pushing that, assuming my Wi-Fi is still active, means there we go. So this is done. If I now go back into GitHub and go to my pull request, look at that. This is just changed. It's now telling me there is a new check happening, which was triggered by me pushing further changes here. And the check is basically the deployment into dev. If anything were to fail, like unexpectedly fail, it would also mean that this pull request would go into a failed state. So this, whoa, I thought we were going to be able to see the changes happening live, but it was too fast. So basically, all checks have passed. When I go to checks and details, I'm moving across to actions, and I can see this particular action ran 20 seconds ago. No, 17 seconds ago, and it took 27 seconds in total. And how can I tell that something's actually changed? If I go back here to my info page, and I'm going to click refresh on the report now. Pay attention on data updated. There we go. Did you see that? It just changed to 5:51, which is UTC, so which is exactly now, right? And so, yeah, that's pretty much the automation and the feedback and the interaction you've got as a developer. I feel like I'm bombarding you with stuff here. Any queries or concerns or comments? Perfect question, really. don't, if someone makes a lot of changes and sort of commits into a particular pull request over an extended period of time, doesn't it get really difficult to review, or almost impossible, right? That really is an anti-pattern, right? And that's really something you need to address in terms of process, right? This is not where tooling helps you. This is where process comes in, which is why I started off saying a release is represented as a milestone, and milestone is represented as individual issues. Each issue should be quite atomic in terms of what's actually happening, right? If you follow that very carefully, you don't have that problem, right? But it requires someone, to sort of be in a leadership position, like a tech lead or so, to enforce that, and it takes time and training and frustration and learning. Yes, thanks. Right. So, so since we're talking different environments for our data sets, how and let's say we have thin reports connected to them, how do we sort of keep them going through the environments, right? Well, I mean that's also a process question, right? So I look at this sort of as a layered system, right? So you basically have data engineering at the bottom, right? This is making sure that you even have the data you want to report on in place, and you're talking data warehouse or something like that, right? Then on top of that, you've got data models, and we're talking Power BI data sets. And on top of that, you've got reports. So you always got to start, you always got to go bottom up, basically, in terms of making changes. So in that regard, I don't think you necessarily have to have all artifacts move in conjunction through the same environments, right? If you report updates in my world work in the exact same way. You know, we basically sit down, we plan a release upfront, we plan what goes in there. If we have a dependency on a model change, we need to make sure that that model change happens first and goes all the way into production before, or at least into staging, before report developers can then actually take that and start their work, right? So that would be my response here. If you don't want to work in that way, there's nothing preventing you at all from maintaining your report and your model sources in the same repo and basically always deploying them in conjunction, right? I mean, that's definitely something PBI-Tools would be capable of as well. Let me help you understand your question. So you're talking about communicating model changes that might impact existing reports? Right. Again, from my point of view, that's not a technology question, right? That's a communication question. And how to automate model deployment is actually also something I'm quite interested in. I've done some prototyping, but it's way too early to. Did I say deployment? I meant model documentation. Sorry. How to automate model documentation. So that's something I'm very keen on, but that's effectively what we're talking about here, right? The other thing is breaking changes versus actually having evolving models, right? So I, in my world, try very, very hard to actually avoid breaking changes. Breaking changes meaning you change something in a model that will render a visual invalid, right? Because I mean, particularly in a system where you embrace centralized models, but then lots of thin reports owned by others, you have very little insight in terms of what are those reports and who's done what in those reports, right? So, I mean, what could be a breaking change? Something gets removed or renamed, right? I normally hide it instead of removing it. That means it's not available for new reports. or for further report changes, but at least it's not going to break anything, right? You adding anything is not a breaking change. That's a new feature, and they will just know once you tell them. What else? I mean, you could change relationships, which would impact how certain calculations are done, right? But well, that's, yeah, I mean, at some point there are limits and you have no choice but to communicate, right? So question is about timing and delivery, really. How quickly can we turn things around following this process, right? So I would distinguish between setting up a new project, almost prototyping or having a POC, as opposed to maintaining an existing project, right? And those are completely different sort of pieces, right? When it comes to setting up something from scratch, from my point of view, anything goes, right? I'm not even keen on a particular process. Just get something out as quickly as possible. Whatever makes your stakeholders happy, right? But once something is out and shared with senior managers or so, then the process kicks in from my point of view. Then we take ownership in terms of now we have to support it, which means any subsequent changes go through the process. Oops, sorry. And any subsequent changes have to be planned and documented, right? So that's first. So that's a distinction I would make, and then everything else is really just about management capabilities. I mean, only because you start. I mean, what are we effectively doing here, right? Assuming that the pipeline is already set up, right? The only thing I'm doing in terms of overhead is basically speccing every single change that we're expecting to work on. That needs to happen in any case, right? So we might as well use a tool for that as opposed to just having a chat or send some email, right? There isn't really much else overhead, I would say, and everything else comes down to people and actually, the team being fully up to speed with the repository structure and committing and pull requests and all of that, right? So that takes time for the team as well to get better and faster and faster. And yeah, that's you're not going to get there overnight. I'm still working with my team, frankly, to sort of take some of the friction out of it, but it's definitely worth it. Right. So question is on metrics in terms of your development cadence and throughput, because using a tool means actually we're generating a lot of data, right? We've got data in terms of how many pull requests there are, how many subsequent changes pull requests have, how many commits there are. That's not something. I mean, yes. In an ideal world, absolutely. I'm not in a position right now where, unfortunately, I can afford to invest too much into that. I wish I were. Yeah. Would you be able to push a PBIX file to GitHub, which is more than 100 meg? Would you be able to compare the that? Well, I mean, theoretically, yes. However, that wasn't the topic of this particular talk, right? So I'm talking about XMLA deployments here, which are basically metadata only, right? So no data gets pushed across. No data is held in the repo. That's only happening within PBI service as a result of actually running a data refresh, right? So pushing a hydrated PBIX file that contains the model and the data, that's the pro scenario. That's not the premium scenario, right? PBI-Tools would be capable of doing that, and I've actually done talks about this previously. It's just not what we're discussing today. All right, so model metadata. That's something which matters a lot to me, and this is something which PBI-Tools supports natively. So we're looking at the report page here, which actually shows us what's the dataset version, when was the data last updated, what's the environment, and then we're even getting some metadata straight out of GitHub telling us what's the run ID for the action that deployed this particular dataset version, right? So I just want to talk about how that's done, because those are, apart from the dataset version maybe, but all the other items in here, those are not things we can keep in source control. Those are not things we know statically. Those are things which are only determined at the time of deployment, which basically means PBI-Tools, as part of the deployment, injects certain metadata into the model so that when I look at the model in PBI service, I can see stuff like what's the environment it was deployed from, etc. So just want to show how that's done. And then we can do either pizza or more questions. So what I've got here is, and this is a standard I'm following in every single model we've got in place at, in my team. We always have a table called info. It's a measure-only table. So if you go and look at this in your data set, so for instance here, create report, we can see over here, that's the one. We basically have 6 different measures in here, and they all just return a single value, which is basically meta information about the deployment or the version of the data set. And this is pretty much how it happens. So this is a Power Query static table with 3 columns: label, timestamp, and text. The label basically determines what is the type of information, and then over here for data updated, we're basically just taking datetime UTC now. So that means whenever this particular query, whenever this particular table is refreshed, obviously UTC now returns a new value. And so at the time of refresh, that gets updated, and we automatically have the timestamp injected here, which is also why it was important for me to do a full refresh as opposed to do an automatic refresh, because an automatic refresh wouldn't pick that up, actually. It would think that this particular table didn't need to be rerun. And then the other items, 1, 2, 3, 4, 5, we can see are actually Power Query references. So those guys reference parameters. So a GitHub branch, for instance, as we can see, is a parameter of type text. It in my development version, it just has a placeholder in it. It's called just GitHub branch here. But what happens at deployment time, you probably guessed it already. So as part of my manifest, I've declared a bunch of parameters. There we go. And you can see the name of those parameters happen to match the name of my Power Query queries, basically my model parameters. And PBI-Tools basically injects whatever the manifest has at the time of deployment, and for the version, obviously that's sort of static. For the other items, I'm taking advantage of the fact that GitHub automatically provides certain environment variables which contain things like the branch name, the run ID, or the SHA commit ID, and using this particular syntax with percentage signs, PBI-Tools knows that this is an environment variable reference. So basically, when PBI-Tools runs inside GitHub, it will automatically resolve those environment variables. It will inject them into the model, and this is then how it all ends up in my report, because every single one of them then has a corresponding info. Here we go. Has a corresponding measure. So branch, for instance, there we go. Simple DAX, right? Lookup value. Give me the text where the label happens to be branch, right? And that's the pattern which is used for all the other 5 measures as well. Yeah, so very neat way, I think, of getting additional information injected there. I mean, the sky's the limit here, right? Those are a few examples. You can do all sorts of things with that. Anything that's available as an environment variable or so can be injected. The other thing that's also happening is those parameters are basically deparameterized. I'm not sure if that's a term. So basically, in Power BI Service, any of your parameters you have declared show up here. And in fact, if you've got edit permissions on the dataset, you can go in there and change them. And I don't want that for those metadata items. So not only are the values overwritten, but the parameter meta tag is also removed, which means it's a static value. It only exists in the model, and you can't access it using Power BI Service. Yeah, so wanted to share that. And then let me just wrap up in terms of other items. So this slide deck I'm going to share with you if you're interested. There's a slide here explaining the deployment manifest. Yeah, keen if you're keen on hearing more or staying in touch, follow me on Twitter. That's where I happen to be most active, or LinkedIn. Check out PBI-Tools on GitHub. Go to PBI.tools, that's the website. If you like what you heard and you actually wanna rock in that sort of environment, I'm currently recruiting a enterprise data architect who will actually own this very process. So this is a very important role to me, and I'm really keen to find the right person here. Yeah, obviously couldn't resist taking that opportunity. Any other questions?